Okay, in the third experiment, we will see counters in the ladder diagrams. Okay, so we have two important counter blocks. These are the up counter and up and down counter. We also have a down counter, but for this experiment we will use the CTU count up counter and the CTUD count up down counter. Okay, so the CTU block, the up counter, works like that. It has three inputs: the up count input, reset input, and PV input. So the up count input is the enable input. So if you give a pulse to that input, the counter value increases by 1. Okay, so it counts up. So initially it is 0. If you give a pulse to this CU input, it becomes 1. If you give another pulse, it becomes 2, and so on. Output of that counter becomes active when the count value reaches this one, the PV value. So you can set the PV value. For example, if you set the PV value 2, this counter will become active when its count value reaches 2. Okay. Again, to reset it to 0, the count value to 0, we have this reset input. So if you give a pulse to this input, the output will become 0 and the count value will become 0. Similarly, the up and down counter works like that, but it also has a down input, count down input. Okay, so it works like that. So when you provide a pulse to count up input, CU input, the count value increases by 1, and if you provide a count down input, it decreases by 1. For this one, again the output becomes active when the count value reaches P value or preset value. Okay, if the count value is greater than PV value, again the output of the counter will stay active. Okay, this is also true for the CTU counter or the up counter. So to reset this count up and down counter, again you have to use the reset input. So if you give an input to reset input, if you give a pulse to reset connection, count up and down counter will also become, its output will also become 0 and its count value will be 0. Okay. So in the first task of the preliminary section, here we must write a PLC program to obtain this waveform. So what that waveform indicates? If we give 1, 2, 3, and 4 and 5 pulses with this input I00, the output must become 1. But if we give another pulse, if the pulse value or the count value reaches 7, this must become 0. Okay. So for this, we will use two counters. The first counter is connected to I00. So when you give 5 pulses and also its PV value is 5, the output will become active. The output is M11. Okay. If the M11 is activated here in the last line, the Q00 is automatically activated. But if using the second counter, if the pulse value reaches 7, again we have connected the same input to both of the counters. Okay. If it reaches 7, the count value for the second counter, it will activate this M12 output, and again it is connected to the reset input, so it will reset this counter. Okay, and it is also connected to the reset of the first counter, so it will also reset this counter, so the output will become 0. So between 5 and 7 pulses, the output will stay active basically. So let's implement it on the ladder diagram. First we have our normally open relay, and we must connect a counter here. Again, at the right side we have this panel from counter operations. Let's select CTU and let's call the first counter C0. Okay, and you see the CU input, CU connection is automatically connected to first relay, and let's connect it to I00. Okay, and reset is connected to M12, okay, and PV value is 5, the count value, and the output is connected to M11, okay. Alright, these M connections are memory connections. Up until now you see you saw I connections and Q connections. I and Q signals or connections are physical connections. I indicates input, physical input, and Q is the physical output connections. They are physically available on the PLC device, but M connections are indicated by memory, so they are memory connections. So M means memory, okay. They are virtual signals, so you cannot provide them to outside physically, but they are the values available in the internal memory of the PLC device, okay. So let's connect the second timer, again an up counter. Let's call this one C1. All right. Again, let's connect the reset the M12 and PV values 7 because you know from between 5 and 7, and output is M12. Okay, and the last line is the output line. We have one relay and the output. M11 activates the Q00 physical output. Okay, so if this counter reaches 5, this will become active here, and automatically the output will become active. If this second counter reaches 7, the PV preset value, the output M12 will become active, and if this is active, it will reset both of the counters because you see we have connected M12 to reset inputs of both of the counters. Okay, and automatically the output will be 0. So let's download it onto the device and see. Okay, there is a mistake. Yes, here we must also provide the up counter input, also I00. Let's load it again. If you make a mistake in the ladder program, it will warn you and you have to fix your mistake. Okay, load your configuration. All right, let's enable the monitoring. All right. Now the count values are 0. Here you see the first count value of the first counter is 0. Count value of the second counter is also 0. So let's give passes. Now I will give 3 passes with this one. 1, 2, 3. Here you see count values of both of the counters become 3. So it counted up to the 3. So let's give another 2 passes, 4, 5. Here we have given 5 passes and you see the output become active automatically because it reached 5. Okay. In turn, this will disactivated the Q00 because M11 is activated and the physical output Q00 becomes active. So the second counter is also 5. So let's give another 2 passes, 6, 7. Here it reached 7 actually. Now it says 0 but it reached 7 and automatically this become active, and after it become active this immediately reset both of the counters and both of them return to 0. So let's see it again. 1, 2, 3, 4, 5, 6, and here now I will give another pass and you will see it will immediately reset 7. Okay, so this is the operation for the first task. Okay, in the second task here we have to implement a circuit such that it will implement this waveform. So here again we have 2 inputs, I00 and I01, and we have an output Q00, this one, and the counter current counter bit. Okay, so current counter value. So if the current counter value becomes 3, the output will automatically become 1. But if it is less than 3, so for example, if it is 2, the output will become 0 here. Okay. And this is the current counter value. It must be possible for us to increase and decrease the count value. Okay. For this, we will use count up and down counter. Okay. So let's implement this. Okay, this is the circuit for the second task, preliminary P2 task. Okay. Here we have an up and down counter. This one. Preset value is 3. So if this reaches 3, this count value reaches 3, the output will become active, and this will activate the Q00 output. If again we increase the count value, for example, if it becomes 4 or 5, again the output will stay active. Okay. But this time we have another input, I01, countdown input. So if we activate this input, this will decrease the count value of that counter. So for example, the count value, if the count value becomes 2, so less than 3, less than the preset value, the output will become deactive or 0. Okay. In that case, Q00 will become deactive or 0. The second counter is preset value of the second counter is 7, and this controls as this is put as the stop function for the circuit. Okay, so if this second counter reaches 7, this becomes active, and this is connected to the reset of the first counter. So this will reset the first counter if it reaches 7. Okay. If this counter is reset, again the output will automatically become 0. So now let's enable monitoring and see the operation here. Here, let's see here. Okay. For the first counter, I will give 2 passes, 1 and 2. So now the count value is here 2, but the counter output is 0. If I give another pass, okay, the output becomes 1, and this activates the last line, and Q00 becomes active. If I give another pass, this becomes 4, and you see still this line is active. Now I will decrease the count value by activating this input, I01. Now it is 3, you see, but the output is still active because preset value is 3. If I give another countdown input, so count value becomes 2, and the output is deactivated because the preset value is 3, and this is less than 3. The count value is 2. Okay. Also, you see the second counter also counts the total inputs, but because it is connected to I00, it stays at the 4. It is not. It cannot be decreased. Okay, because this is the up counter. So let's give another up count and make it 3, but this becomes 5. And let's give another 4, and this becomes 6. Let's decrease this one to 3. Again, you see this stays the same, and this is nothing happened in the second counter because it is connected to I00, the up count input. Let's give a last pass and make this one 7. You see immediately when this becomes 7, this is activated, and this output resets both of the counters because it is connected to reset inputs of both counters, and in turn the main output becomes 0. This is the expected behavior from the waveform given in the second preliminary work. In the third section of the preliminary P3, we have this waveform, and we must implement a ladder circuit implements this program. Okay, so we have 2 inputs, I00 and I01. I00 is the basic start-stop implementation. So if you give one pass to I00, the output is activated. If you give another pass, it is deactivated. So we will use 2 counters. The first one will be active after 1 pass. Its preset value will be 1. And the second counter's preset value will be 2. And it will deactivate after 2 passes. Okay. And in the second part, we have I01 input and Q01 output. If we give 3 passes to I01, the output will become active, 1, 2, 3, okay. But if we give another pass, the fourth pass, it will become deactive. Okay, again, if you give third pass, 1, 2, and 3, it becomes active. If you give another one, the fourth pass, it becomes deactive. Also here, 1, 2, and 3 at the third pass, again, it becomes active. But here you see the I00 is activated again, so this resets the whole circuit. So the output becomes deactive because Q00 also controls the Q01 output. Okay. And now let's see the implementation on the ladder diagram. Here, these two counters are the implementation for the start and stop. So they control the Q00 output. Okay. Here, let's see this line. Okay. You see the M11 output is connected to Q00. So if this first counter becomes 1, the preset value is 1, the output becomes 1, this one, M11. If M11 is activated, Q00 automatically becomes active. If we give another pass to second counter, C1, its preset value is 2. So if we give another pass, this time this becomes active, M12. If it is active, it is connected to resets of both of the counters. So it resets both of the counters, these two counters, and this Q00 output becomes 0. This is the first part. For the second part, again we have two counters, C2 and C3. Their count up inputs are connected to I01, okay, same input. So if we give 3 passes here, this output becomes active, okay. If it is active here, also the Q00 controls also this output. So if Q00 is active and M13 is active, Q01 automatically becomes active after 3 passes. For this counter, if we receive another pass and if we reach 4 passes, M14 becomes active, and M14 output is connected to resets of these two counters, similar to the first part, okay? So we have connected resets to another output. So if this reaches 4, this resets both of the counters, both this counter and this counter. So their outputs become 0 and the output Q01 automatically becomes 0. Also, another thing, here for the reset input, we have connected Q00 using a normally closed relay in parallel to M14. Because if this output is deactivated, we must also reset these two counters. Otherwise, their count values will stay the same, and this is not the desired condition. Okay, it must be reset to 0. So now enable the monitoring, and let's see the operation. Initially, you see the output is 0. Let's see here, and I will give pass here. So if I give one pass to I00, you see the count value becomes 1 and the output becomes 1, and Q00 becomes 1. If I give another pass, this will become 2 and this will activate this one and it will reset these counters. Okay. So now let's reactivate it again and see the second part. Okay, this is the second part. Here I will give 2 passes, 1, 2, and you see both of the counters values become 2. If I give a third pass, you see this becomes active, and in turn this Q01 output becomes active. If I give another pass, this will become 4 and this will activate this one, and it will reset both of the counters using these reset connections. So I will give the pass now, and you see the output become 0. So let's give again 3 passes, 1, 2, 3. Okay, you see the now output is active, but this time I will deactivate Q00 using the I00 input. Okay, now observe. Okay, now this becomes 0, Q00. Because this is reverse connection, normally closed, this enables the reset and the output is again reset. And this is the expected behavior from the waveform.